各位在线上观看 Computex 2022年的朋友们，大家好，我是资策会的产业分析师苏伟刚。那我个人的主要研究的领域是有关于 5G 还有开放网络架构相关的发展趋势。那接下来的简报我也会跟各位做一下有关于全球的 5G 发展的状况，还有我们未来对于 5G 发展趋势的一些相关分享。那以下就请大家来开始观看我的简报的内容。好，那么今天的简报大纲主要就是先谈到国际的 5G 发展趋势，还有它的概况。那最后我们对于整个 5G 发展趋势的概况会带来一些机会，还有做一些结论。那首先我们先来谈国际的 5G 发展概况。那首先呢，我们看到 GSA 它本身有去对全球营运商的一些 5G 服务做了一些统计。那我们目前可以看到是大概全世界有超过140个国家，那大约有超过450家营运商已经在投资 5G 了。那其中大概有70几个国家的182家营运商，他们 5G 也已经商用开台。那值得各位注意的一个点在于说，全球目前现在已经有快接近50个国家的接近100家营运商在开始在做 5G Standalone， 就是独立组网的部件。那这一块是未来我们看到 5G 的其中一个发展趋势，那在后面我们也会再做详细的说明。那第二个重点是，目前大家在 5G 在国际上面在谈论的时候，他们谈到很多东西是有关于开放架构，也就是所谓的 Open RAN。那在 Open RAN 这一块，其实我们也可以看到说，在2021年到年底的时候，我们大概已经看到全世界有28家的以上的营运商，他投入在 Open RAN 的开发测试，或者是他直接去做 Open RAN 相关的采用。而其中最重要的是像乐天行动、Dish 和德国的 1&1，他们都已经宣布会去做全国性的 Open RAN。那我们接下来也会预期得到是到2022年甚至2023、2024以后，也会有更多有关于 Open RAN 的一些测试，甚至是部件的方案开始会出现。好，那接下来我们就来谈国际在 5G 上面的发展趋势。国际在 5G 的发展上面呢，我们首先要先看的是网络架构在 5G 时代产生什么样的变化。第一个最主要的变化是，过去我们在谈这些网络的功能还有网络设备的时候，它都是一个一个个别单一的硬体。但是当我们接下来看到从 4G 时代接下来开始发生的网络功能虚拟化这个变革，那网络功能虚拟化这个变革就造成我们以前看到的这些单独的网络功能还有这一个一个的设备，它开始变成是用软体安装在伺服器里面。所以我们可以看到的是，在 NFV 这个技术发展出来之后，我们看到这些网络的设备变成的是伺服器加上了一些软体。那在伺服器加上软体之后，我们到了 5G 时代，又面对到了 5G 的网络架构，它开始从 4G 时代的核心网络到 BBU 再到 RH， 转变成分拆成更多的设备，包括 CU、DU 还有 RU 这样子的设备。而这样子的网络功能和网络架构的分拆，再加上整个网络功能从硬体变成软体的这种趋势来发展之后，我们就会看到各式各样的界面开放出来之后，就产生出我们现在在谈的开放网络架构。那开放网络架构此外，因为我们的所有的网络功能可以开始变成是用软体的方式来提供，所以我们也可以看到有所谓的云端核网和那个云原生网络的这种形式。那到了 5G 网络正式开台之后，我们一开始所看到的 5G 网络是所谓的 non-standalone， 就是非独立组网的部件方式。它的意思是说，我的 4G 网络跟 5G 网络是共存的。那当然，在 5G 的慢慢发展之下，这种 non-standalone 的部件方式会慢慢的转移到 standalone， 就是单纯全套唯一的 5G 网络的形式，这样的方向去做发展。所以我们接下来看到第一个就是5G 势必会朝着 standalone， 就是独立组网部件这种形式去做发展。那这种形式去部件发展的时候呢，因为 standalone 它是真正的 5G 网络服务，那它可以让我们的整个 5G 的市场还有 5G 的产业能够真正看到 5G 到底会带来的这些所谓大频宽、低延迟还有大量连接的这些特性真正的去实现。那所有的营运商，全世界各国主要的营运商在看到这样的5G 独立组网能够让大家得到真正的 5G 服务之后，当然大家都去急于说要去做这些 5G SA 的部件。然而在谈到 5G SA 部件这件事情的时候，大家还是会有不同的部件跟思维的模式。那有一群营运商，例如像 T-Mobile 或者是 KT， 他们的想法就是我希望是一步到位。那所以他们的做法就是我不管中间的过程是什么，我就是直接 把 5G 走 5G standalone 的这种所谓的 3GPP Option 2的模式，直接一步到位把 5G 的独立组网建出来。那但是这样子的建制模式的话，它会造成一个问题是，因为 5G 的部件它的基地台覆盖并没有这么的完整，尤其是它跟 4G 去做相比，它的部件的范围还有部件的讯号覆盖能力可能没有像 4G 这么的完整。那么如果我们直接进到 5G standalone 的时候，它势必会产生某些地区某些人他会收不到 5G 讯号。那在 standalone 的模式之下，它如果收不到 5G 的讯号，它就是没有其他的讯号可以做使用。那为了要避免这样子的讯号覆盖不足的问题，所以有一部分的营运商，例如说意大利的 TIM， 然后还有 SKT， 他们的做法就变成是我求取一个渐进的方式，我采用 3GPP 的 Option 4， 也就是说我让 4G 和 5G 一样都共存，但是我主要的核心是在 5G 的核网，然后 5G 的基地台，同时透过 4G 基地台提供的覆盖范围去补足我 5G standalone 不足的这些讯号覆盖。那这是完全不同的部件的思维模式，但是不管在 standalone 的部件模式是采取 Option 2或者是采取 Option 4，它最终的目的都还是要往 SA 这个方向去做前进。那当我们的 5G 网络去朝 SA 的方向前进的时候，我们可以看到的变化是，当我们在 NSA 这个架构底下，我们所看到的 5G 最主要提供的是大频宽这个功能，所以我们看到这些应用就是例如说在工厂里面的光学的自动检查，然后 ARB、AGB 等等，这些都是跟影像尤其是上传相关的应用。但是当我们走到 SA 的时候，我们可以真正的感受到的是 5G 它带来的更大的频宽、更低的延迟，还有大量部件这些好处。那么我们预期的是，当 5G 走上 SA 的时候，它会除了我们所看到这些需要做上传的影像应用以外，它能够再产生更多，例如说需要低延迟的这些人机协作，那或者是需要大频宽，同时要延迟率又很低的远距操作。而更重要的是，当 5G 走上 SA 的时候，它还会有一个很重要的新功能，叫做网络切片 Network Slicing。那 Network Slicing 这件事情，它最重要的重点是能够把我们各种不同的需求、各种不同的应用分做不同的网络切块，然后在各种不同网络切块去给它适合它所需要的这些网络品质。而这个网络切片的功能也是未来能够帮助我们像例如说像产业的各种应用上面非常非常重要的一个新功能。而这也是我们在看到 5G 往 SA 的时候发展最重要的一个重点的发展趋势。那这些东西未来都会带来除了影像应用以外更多不同的新的 5G 应用。第二个趋势则是，因为我们先前提到的是说，当网络功能变成虚拟化的时候，很多的网络功能改成用软体的方式来提供。那当网络功能改成用软体方式来提供的时候，它就对云端的业者产生了一个新的机会。那么我们上面所看到这张图就是 AWS 它跟地区所合作的所谓云端核网。那这个云端核网的模式最重要的概念就是说，它把许多的伺服器本来要安装在营运商自己的资料中心，或者是安装在基地台的一些伺服器，变成放在云端业者的资料中心里面，然后透过在云端业者的资料中心里面安装我的核网软体来提供电信服务，不管是我在公用网络或者是在专用网络上面都可以做提供。那这样子从一般的核心网络移转到云核网的过程之中，它最大的好处是在于它能够让营运商降低它的某些 capex， 它不需要去买很多很多的设备，尤其是核网的部分，它可能就不太需要买太多的设备。那再来的是它可以提升营运商在提供这些服务上面的弹性或者是便利性。例如说，当我们的使用者人数增加的时候，对于传统的营运商来说，假设它的核网不是在云端，那它可能会需要布建更多的 CU、DU 还有核心网络来负担这样的 capacity。但是如果我今天是使用云端核网的时候，那当我的使用者人数一增加，我只要在云端核网上面把那个云端所开的 capacity 增加，我不需要再去增加我的硬体设备，马上就可以做处理。那所以这件事情能够对我们整个电信服务产业来说，它第一个是能够降低它的成本，第二个是让整个服务的弹性能够提升。那由于是因为我们又解放了它不需要去购买很多硬体设备，所以对于这些电信服务来说，它又可以产生出新的营运模式。那当然还是有一些电信服务业者他不太信任云核网这件事情，例如说 Verizon 他就不太愿意去把他的核心网络放在所谓的公有云上面，他比较愿意是利用私有云 或者是与公有云的云端业者合作的部分只限于在专网这一块。但是无论如何，在整个新的 5G 的网络架构的情况之下，云端业者他投入到电信服务这一块已经是进行式了。那我们如果再去看到云端业者跟营运商它的整个竞争跟合作的模式来看的话，这张图上面显示的是我们如果要提供一个电信服务，我们需要哪些的硬体跟软体设备。那我们总结来看，就是对于云端业者而言，他要取得这些硬体或软体设备，基本上它大部分我们看到它已经存在了，它已经可以取得了。包括核心网络，它软体是使用像 Mavenir 或者是 Pearl Wireless 或者是那个 Urban 他们这些第三方的核心网络，然后硬体设备使用一般的所谓的 server 或者是他们自己开发的一些硬体设备。那再来到网络部件这一块的时候，才是云端服务业者他现在要进到电信服务这一块里面，他最大的一个问题，他在网络部件上面他比较难去找到说除了跟所谓的铁塔公司合作之外，他可能就不太能够说去自己去做网络部件等等，至少我们到现在还没有看到相关的这些案例。那至于频谱的部分，这些云端业者他们例如说Amazon AWS 它本身在提供的所谓的 5G 云和网中网服务，它就有在考虑的是他想要去用 unlicensed 就是免授权的这些频段来提供所谓的 5G 专网服务。所以我们如果从这整个结构来看的话，会发现对于云服务业者他进到电信市场里面来这件事情而言，它最大的进入障碍基本上就是它必须要有网络部件跟所谓的频谱。那这两件事情如果说云端服务业者能够克服的话，那么云端业者接下来就可能会跟电信服务商，就是这些所谓营运商产生出了直接竞争的关系，而这也是我们在目前看到的第二个 5G 网络的发展趋势。那接下来我们要谈的是说，在我们看到这些趋势之后，对于台湾跟对于全球业者来说，它有什么样的机会？首先第一个是当整个网络走上了分离式的结构，有更多的不同的设备 RU、CU、DU 这样不同的设备，再加上整个网络走上了开放网络架构这种路线之后，我们可以看到的是，因为台湾有着非常非常完备的 5G 生态系，我们从零组件，然后到终端设备，一直到接续网络，还有局端的设备，台湾的厂商都有供应的能量。那所以从这个角度上来看，或许台湾能够在整个网络走上开放，并且有更多的那个网络设备的拆分之下，台湾的厂商是可能有一些可以进去的新的机会。那当我们在看到这样的新的机会之后，我们再来看，也的确可以发现到的是，台湾的网络厂商，就是不管是网络设备或者是通讯设备，甚至于是 ICT 的业者，他们已经有一些网络设备已经达到了国际的电信运营商市场，例如说启基、友达、台阳等等的厂商，他们的设备都已经进到了国际的营运商里面了。那所以我们从这个角度上来看，就是当整个 5G 网络走上了更多不同的架构的分离，以及整个开放网络架构的时候，那再加上 5G 它朝向 SA 会有更多的新的应用服务的时候，我们会看到的是它会带来很多的新的机会跟挑战。例如说，当开放架构的发展之后呢，很多的硬体设备它会从本来用 Nokia、Ericsson 的这些品牌设备变成转由像台湾的网通厂商去提供一些白牌的设备。那这对于厂商来说，它是一个新的设备可以销售的机会。那同时在云和网这一块，如果是云和网在搭配开放网络架构的时候，那它同样也会带动一些像 RU 或者是小基站这些设备的需求。那但是当我们在考量到说有这些设备的需求的时候，我们需要考虑的几个挑战跟问题点就在于说，当这个市场越开放，然后他认为是变成所有的设备厂他都可以有机会进到这个市场的时候，供应商的数量变多，它可能代表是这个市场的竞争的强度也会随之提升。那再来第二个是开放网络架构这个东西，它的重点是整合。那么单一一个设备的厂商，它可能要再进到这个市场里面，它是相对比较困难，它必须要跟其他的业者合作，成为其他已经整合了方案的业者的供应链体系之一。那或者是说，它必须要从单一的系统硬体设备的业者转成是系统整合业者，提供一整套的 turnkey 的方案，它才能够进入到这样的一个市场里面去。那再来是像 5G 如果往 SA 这个方向去发展的时候，它会促使我们的 5G 有更多的产业应用。那当然 5G 有更多的产业应用，这样的一个机会是可以发展的。但是当我们在思考 5G 更多产业应用的这个背后， 我们最终还是要思考的是，那它有没有它的获利模式？那又有什么样的应用是能够吸引人们一定要使用 5G？ 这就是我们所谓的 killer application。那我们现在整个 5G 的市场都还在观望，到底所谓的 killer application 到底在哪里？什么时候会出现？这也是我们在看 5G 的这各种应用的时候需要去关注的一个问题。再来是云核网这个东西，它如果使用在专网的时候，它能够去降低我们在导入专网的成本。那当我们降低导入专网的成本的时候呢，除了能够提升就是各个垂直领域的业者它导入专网意愿之外，它还能够为我们的专网提供了很多新的营运模式，包括说不同的架构模式、不同的组件模式，或者是不同的收费模式等等都会发生。那同时因为云端业者它有可能是跨国营运的，所以它也代表的是未来专网系统它有可能也能够做跨国营运，这是如果使用云核网去进到专网这一块市场的时候它能够带来的机会。然而更重要的重点是，云端业者他可能没有办法直接去满足各种不同的垂直应用他所需要的这些不同的know-how 等等的东西。那这是在地的这些业者或者是在地的某些特定领域的 SI 他可以去强调的点。那再来是说，当我们的业者他需要去进到整个专网市场里面的时候，他还是必须要去建立他自己在专网这一块的整合跟部件还有营运的时机。那这样才会有业者愿意去相信对他们做得到。那么以上就是今天对有关于 5G 还有开放网络架构等等议题的一些简单的分享。那么谢谢大家今天的聆听。
Hello everyone, I'm very honored to be here to share the experience of deployment new trend in 5G private network and create a new type of smart application. I'm VP of Chunghwa Telecom Mobile Business Group. I'm Dr. Jia Zhongyong. Okay, here is my agenda. I want to show what is 5G and what is 5G in enterprise private network, and what are application that we can be on the private network. And that's the end of the conclusion. So what is 5G? 5G is high, low, big. We have three technical characteristics. High is mean high rate. Compared to 4G, 5G has 10 times speed to 4G. And low is mean low latency. It's only 1/10 of 4G. And big is big connection. It's only 1,000 times compared to 4G. So in Mandarin, it's 高低大. In 5G, that has so many applications that can be achieved. In 4G, that we cannot do that. Okay, here is the 5G frequency band. Taiwan adopted the mainstream frequency band in the world. In this slide, that you can see so many countries use 3.5 GHz, including Korea, China, Japan, Singapore, Europe, also in Taiwan. And USA is a different use another bandwidth, including 628, 39D. And besides the 3.5G, a little country use 700 and 2.1G, including Taiwan. Okay, so if you want to build 5G enterprise network, we can use Mandarin in 3.5G. Okay, according to the Nokia document, there are 75% of the enterprise, including these four industry, including the manufacturer, transportation, energy, and government utility. So if you want to implement the 5G private network, you can share the experience what I'm talking today. Okay, so what is 5G enterprise private network? In this slide, we compare the traditional enterprise network with the 5G private network. The traditional network, maybe you will use wire. Wire is mean fixed line. or Wi-Fi. But Wi-Fi has small coverage and there is some influence. So maybe some enterprise use the NDVPN. NDVPN is mean that you can use the mobile and to access the data network. The traffic will go from base station to the core network and to the internet and go to the enterprise. But there is a long latency. With 5G, because we have high, low, and big, the new technology is that 5G private network. We can build MEC in this size. MEC means that Edge Computing Network. It's a dedicated server in your enterprise. So when you want to use the 5G private network, the device will connect to the base station and also go to the MEC and local breakout to the server you built in your enterprise. So compared to the Wi-Fi, also the wire network, 5G enterprise network will have low latency and they can have the very, very strong confidence and also local breakout and a secure network. Okay, so there are two options that private network can choose. One is like commercial frequency dedicated network. It means that the enterprise use operator band. For example, in Taiwan, you can use 3.5G or 28 GHz. Also, you can use dedicated frequency dedicated network. In Taiwan, 4.8 to 4.9 GHz is the NCC government want to release to the enterprise. So in Mandarin, one is 商品专网 or 专品专网. So in the slice of the right corner, you can meet if you build use the commercial and the dedicated network, it's use operator. Operator can build and maintenance this for this one. So the bandwidth should be in 3.5G or 28 GHz. If an enterprise want to build by yourself, okay, you can use 4.8 to the 4.9 GHz. You can use the bandwidth and build by yourself. Okay. Also, there is two types of the 5G private network. One is NSA, non-standalone. Another is SA, standalone. What does that mean? What's the difference between that? In the slice of the left corner, 5G NSA architecture is mean that 5G base station should combine with the 4G base station together, and the terminal can use download or upload, use 4G and 5G at the same time. But in SA, it means that the terminal to access the 5G network only by 5G base station. So the difference and the compare you can share in this size. They are in right now enterprise, maybe in Chunghwa Telecom point of view, enterprise can build NSA first and then upgrade to SA when it mature later. Okay, so in Chunghwa Telecom point of view, that we can share some application in the 5G enterprise if we want to build. In this slide, that there are so many applications right now. Maybe not mature, maybe some mature in Taiwan. One is smart manufacturing, smart city, AR, VR application, smart inspection, also remote care, smart video, smart metering, or smart agriculture. Maybe if you want to use one of them, you can build the network by operator, or you can build by yourself, use different frequency band. Okay, so I will introduce one of them detail. One is smart manufacturing. If you want to build a smart manufacturing, you can build a MEC in your enterprise. So you can share the high rate, low latency, and the big connection in your enterprise. So I think right now in Taiwan, so many enterprise use the Linux9 or Wi-Fi. So if you want to introduce, you want to have some high rate, low latency benefit, you can use 5G and they will have so many this benefit. Another is that small city. Okay, in the city for the government, if you want to have a city TV on your light, okay, so you can use MEC in the government site. In this site, we have MEC connect to the base station, or also has a core network and the internet. But when the government want to use a smart city, they connect to the base station and MEC again and get local breakout to the server the government built. So if you can share have so many benefit for the latency, and so many bus can connect to the MEC at the same time. And also the AR/VR application, the engineer can at a remote site and can introduce the some method controlled by the remote site. So when the enterprise want to build AR/VR application, they can build 5G enterprise first, and then you build your MEC. So many methods can use the MEC and local breakout by your application. And also smart inspection. The drone can have some machine in your area, so the server can build in your enterprise, and the MEC, that the core is mean MEC, so you can share and some benefit get from the low latency and the big connection from the drone. Okay, so that's my conclusion remark. In Chunghwa Telecom perspective, primary network should construct to consider the future. So you can build your 5G NSA first, and then upgrade to the 5G SA again. Of course, you can choose dedicated frequency. In Taiwan, NCC released 4.98 to 4.9 gigahertz. You can build by yourself, use this band. Or you can build your 5G and private network by operator. Use the commercial frequency band released to the operator. For example, 3.5G or 28 gigahertz. And in Chunghwa Telecom perspective, I think commercial frequency dedicated network is better to the dedicated frequency band. Why? Because for the operator, we have so many experience. We can consider the network spectrum, CapEx, OpEx, and you can very easy to upgrade in the future from NSA to the SA. So, of course, Chunghwa Telecom is the best choice partner for you to build your 5G network. I'm very glad to be here to share the experience of Chunghwa Telecom. Thank you.
Hello everyone, I'm Alan Yang. On behalf of ICT of E-Tree. E-Tree is a leading research institute in Taiwan, and I have been studying ICT industry for years. Today I would like to show what my research results for you all. Okay, today I would like to show you beyond the 5G, maybe more focused about the non-terrestrial network, especially focus on the LEO satellite communications, and also for the 6G application. This page I will show you for what is important for the communication trend. First is about 4G. 4G changed our life because through 4G, we can use a smartphone to watch videos on your smartphone and have watching video and have online game or even more application just followed by the 4G. And now we have 5G. The capacity is greater and have more advantage than 4G. I think the speed latency and all are greater than or better than 4G. So we can use the AR/VR and the high quality video and even used in the smart cars for the connect to use let every car can connect to the internet. So that is will create more applications in the future. And for the geo satellite communication, I think that is already operated for decades because we are usually heard that use the satellite to send a message, have a phone call, and even transmit videos like satellite TV. So many people can use it because the cover around the world, you can use it on the boat or in the air. So, but now I think the LEO is quite a hot topic for recent years because that is the capacity is more close to the 5G, so they can provide a wide area and more people can connect to the internet. Because I would say that that is quite different, useful in the future. So because that is cover all around the world. So what the LEO satellite advantage will show you at this page. So because that is a wide cover around the world. So far, I think there will be 4 billion of people cannot connect to the internet because of the ground infrastructure not able to reach, or these people are living in the very remote area, or the place is not able to build this kind of infrastructure. So satellite more LEO satellite can cover this area, and also because the technology improvement, so I think now we can afford satellite communication will become more affordable. For example, Starlink just take 99 per month, and also some government will give some sponsor or to support this kind of this area residents to use it. And for the communication capability, I think the latency is quite important because low latency make a video transmission be possible, and even the LEO satellite is more close grounded, so the latency can more close 5G. But I quote Elon Musk. He said that LEO satellite cannot replace the 5G, 4G, 5G, or fiber network because that has its limitations. So if you have a massive applications, I think that they cannot afford it to use all the time. So I think the LEO satellite is just part of a future communication environment, and that is just provide people can use the internet around the world and anytime. Okay, so GEO and MEO have already operated for decades. We already know. So for the video for a TV broadcast, or for a message or a phone call, you can use it. But for many people not familiar with this, only for you climb the high mountains or in the ocean activities, and because the fee is quite high, not everyone can afford it. But under the affordable fare of LEO satellite communication, I think they can not just cover for the remote regions, the oceans, and in the air. So in this area, everywhere, no matter where you are, you can connect to the internet. So that will be great useful for people to have business commercial activities. And for the government, I think that is quite useful for the emergency relief. And for the future application, combine the LEO satellite communication and also for the 4G, 5G, and fiber network. I think in the future, maybe smart car can connect to the internet and also with all the IoT around the city. So we can create a more application based on the smart car. And also we can use the LEO satellite to watch your health conditions no matter where you are. And because for the low latency, I think in the future maybe we can also use AR or VR in no matter for the workplace or for the entertainment. And entertainment, that is quite interesting thing. And currently is the metaverse is quite popular topic. So I think that all combined together, all the technology will let the communication environment able to support a metaverse. And while we have all the everything can connect to the internet, that means we will create a lot of data. So the data center will be more important in the future. Okay. So next part will be the IoT. I think IoT was quite interesting. The most important thing is while the cost can reduce and become more affordable. So in the coming future, I think many companies will try to figure out what can do, especially focus on these 5 areas like the utility, transportation, energy, agriculture, or disaster control. So we can press a lot of IoT to detect all the environment and collect the data and send back to the control center and analyze it, get the useful information and help the government or business to make some decisions, so they can improve their business efficiency, or try to through this sensor and the data to find some creative business opportunities. Okay, and now this year I think the Starlink and OneWeb will be a commercial operating. So many those 4 billions of people through LEO satellite communication, they can connect to the internet. So I think that is quite fast business progress for the next stage. So also with the LEO satellite communication, I think that there will have more imagination, like connect to the car or to the use a robot to deliver your goods, like the Starlink do or Amazon do. So not for the future communication is just the base to explore more business opportunity, not just only use it. I don't think that people only use it to connect to the internet and use your smartphone to watch TV. So there will be more useful applications will be found. And now we can see this page is talk about the 6Gs. We can here I list many countries, and many countries already launched a lot of research projects, and also for many companies announce their white paper about 6G. That means 5G is just a commercial operator for 2 2 years. But now we are thinking about 6G is the future strategy advantages in the future. So many countries are starting for their researches here. So we can see maybe like EU Hexa have launched 9 projects to study about 6G technologies, and also in America they have NextG Alliance to try to leading by the private sector to explore what the future possibilities. And but in China, maybe that leading by the government and try to lead it by the future standard and combine with their China, all those Chinese companies come together to build a group to try for the future 6G studies. And now we already know there are a lot of white paper and projects, but now here we can see basically communication will combine the non-terrestrial network and also for a terrestrial network like the 4G, 5G, and the fibers and the LEO satellite, and also for the hubs like use the UAVs and ballrooms. And for the technology, we are thinking about in the future maybe we'll more focus on the software-based telecommunication. Like vRAN, use AI to increase the efficiency, and for the quantum technology or cloud native, and for the cybersecurity, all about it is more important in the future. And also for the cost reduction, I think for the supply chain reliability will be more focused on the open rate. Let the company or telecom operators can have more choice and avoid like this situation, the supply chain issues. And for the high tech, maybe we are more focused on the chip and beamforming technology, especially for the millimeter wave and the terahertz spectrum, and underwater maybe use in the future they will use the lighter communications. So and for the application, as I always mentioned, maybe in the future will the smart cars and robots and UAVs, all of these things will change our life because everything can connect to the internet. So maybe in the future, people don't have to drive the car, or people don't have to use the manpower to deliver all the goods. Just use the robots to help people to do this. And for the future environment, I think internet is everywhere. So you can, in the future, maybe more and more company will think about what can do, not just the entertainment, but so far, I think entertainment is quite huge business, like a metaverse. Okay, and for the finally, because the global warming and more and more people think about ESG issues, so I think there are more technology about carbon neutral or energy efficiency is more important for the telecommunication industry, and for disasters destroy like a volcano explosion, or for extremely weather like a typhoon, rainfall, or earthquake that might destroy all the basic infrastructure. So they have to back up the solution. So I think in this part we can think about how can combine the 4G, 5G fiber, and also with the satellite communication. here is the future of technology roadmap, and maybe I hope this picture will show you and give you more imagination about the future 6G environment, communication environment. This is what I share to you. Thank you.
Hi all, I am Steve Huang, the Chief Technology Officer and the Senior Vice VP of Pegatron Corporation. I lead R&D centers in developing artificial intelligence, 5G mobile communication, electrical vehicle, and the robust technology. My responsibility is to planning and study the future technical roadmap for corporation. When people talk about the 5G product, first things pops up on everybody's mind is 5G mobile phone. But the reality is 5G network deployment is quite slow. So today, I would like to talk about a very interesting application on 5G smart products. It is also a brand new idea called 5G smart pole. There are three topics in this presentation. First of all, I will talk about the technology which builds up 5G smart pole, then addressing the system diagram and the network structure of 5G smart pole. Finally, the applications of a 5G smart pole system. I will start off the technology which builds up 5G smart pole. Let's talk about what technology the 5G smart pole derives from. Let's go back to a long history ago, about a little bit more than 1 century back to the history. In 1888, in Taiwan, let's look at one high-tech product at the moment. Street lamp. Mr. M.C. Liu, who was the first Taiwan governor, he set up the first street lamp on North Gate of Taipei, using the power from a coal generator. From that time, several generations of street lighting has been discovered and disused, one after another. From light bulb to mercury lamp, and then replace mercury lamp to LED lamp for the reason of more power efficiency. And then a street lighting revolution happened. It is because city government wants to reduce the maintenance cost of a large number of street lights. Every day there are a few lamps get black, but you don't know where they are. You have to send patrolmen to check row by row, area by area. A smart engineer puts a sensor on each lamp to detect the status of lamp and then report back to the maintenance center by NB-IoT communication method. So the maintenance center knows exact the location of the out of order lamps before sending out workers for lamp replacement. You see, this idea is so smart. So we call this is a smart lighting system. This all happens from about 5 years ago, and almost at the same time, another technology trend is undergoing. It is the trend that more and more IoT devices and sensors are installed at every corner of the city. This includes camera, display billboard, air quality sensors, and so on. These devices help watch traffic status, providing environmental conditions, deliver city information, even assist the policeman issue a fine to you. But it also creates a big problem. So many stands, poles, buses everywhere around you in the city. The city gets messy and ugly. Then cityscape planners start to merge all these sensors and IoT devices to smart lighting pole and become a common use pole. We just call it smart pole. Then what is the next step of the smart pole? It turns out to be the appearance of the 5G technology. Since 2019, 5G applications are quickly getting popular. Let's review the 3 major goals of 5G technology. The first goal is to achieve 10 gigabit per second high data rate. It's about 10 times our LTE peak data rate. This makes possible 8K ultra high definition video streaming and 4K VR AR display through mobile network. The second goal of 5G technology aims to less than 1 milliseconds radio latency to implement ultra reliable communication. This capability will make happens of stereo vehicle to everything, C-V2X. It helps exchange traffic information and the vehicle conditions among cars and the 5G stereo small cell in order to achieve higher level of car driving safety. The third goal of 5G technology was to allow 1 million of IoT or mobile devices can smoothly work and transmit data simultaneously inside 1 kilometer square area. This feature can support large-scale mobile communication during music concert and parade. This third 5G technology goal also can help all these smart poles fulfill their large-scale data transmission. Smart pole is the paving stone of the idea of smart city, and the 5G technology is surely an important element to smart pole development. I'd like to explain a little more about the higher density of 5G small cell deployment. A new transmission technology, millimeter wave technology beyond 24 GHz, will dominate 5G transmission methodology because millimeter wave can carry a much higher data transmission speed. But this transmission suffers significantly higher path loss, and then the signal is much easier to block. For most cases, coverage is limited to hundreds of feet. Obstacles such as walls, trees, the roof of a car, buildings, and more may cause the technology to be obstructed. Therefore, dense deployment of small cells less than 1,000 feet in between are essential for 5G millimeter wave spectrum. This explains why smart pole along the street is very suitable for the installation of 5G small cell. No extra infrastructure investment is needed. Another reason that smart pole perfect fit to the small cell installation is the inherent electricity power of a smart pole system, which can be commonly used by 5G small cell. To put it in simple words, the 5G smart pole reflects a growing trend of smart lamp, 5G communication, AIoT, and electric vehicle. Following, I'm going to talk about the system diagram and the network structure of a 5G smart pole. Here is the picture shows a 5G smart pole prototype implementation built in around Taipei City Hall on December 24, 2021. This is a joint forces of Taipei governor and an industrial alliance called 5G Smart Pole Standard Promotion Alliance, consisting of more than 40 high-tech companies in Taiwan. The 5G Smart Pole prototype includes 3 poles and 1 control cabinet. Each pole consists of 4 portions. From the top to bottom, there are top, T-bar, body, and the base. On the top of the pole, it is equipped with the most important devices, 5G small cells and 5G modem, with LED indicator sitting above. Smart lighting and the traffic monitor are fixed at T-bar. On the body of 5G smart pole prototype, AO2.11ad, digital billboard, and the air quality monitor are installed. Under the body of 5G smart pole prototype, a pole cabinet is on the base. A few power equipment and the network devices are stored and function inside of the pole cabinet. The control cabinet of the 5G smart pole system is the main control unit of power, communication, networking, and the controlling. Several important power units, communication, and networking units are installed inside. An electricity meter, which calculates electricity fee, is installed on the top compartment of control cabinet. Besides 3 poles and 1 control cabinet, this 5G smart pole system also consists of a 5G smart pole backend platform, which connects to 3 poles through the control cabinet using optical fiber network. The backend platform executes the network management, data retrieving of IoT devices on the smart poles, commanding and the setting of IoT devices, video streaming, bidirectional among camera and digital billboard. Also, the backend platform executes cloud computing and the big data analysis of the whole 5G smart pole system. This time in the 5G smart pole prototype, it demonstrates some advanced features and establishes some nationwide and worldwide records. The first 5G smart pole system installs 5G smart cells with sub-6 and millimeter wave connection in Taiwan. The first smart pole system cooperates and simultaneous operating with 3 telcos, including Chunghwa Telecom, Taiwan Mobile, and Asia Pacific Telecom. The first 5G smart pole with 5G terminal as backhaul network prevents data transmission interrupted from disconnected fixed network. And it is the first 5G smart pole system which integrates AO2.11ad wireless technology to transmit data among smart poles. From about system diagram and the network structure introduction, you already know how a 5G smart pole system integrates and connected. The last but not least, let's go into deep dive on the applications of a 5G smart pole system. The 5G smart pole system practically provides 5 main group of applications. The application of 5G network communication I have explained earlier. This is actually the 5G backhaul function to use 5G wireless transmission to replace wire optical fiber transmission when the latter is broken in urgent cases. Smart pole backend platform application is also covered in previous slides. For AI technology in law enforcement, it will become more important in the future. 5G smart pole using AI technology by camera and edge computing to detect illegal parking and wrong-way driving. We built a cybersecurity package to block DDoS attacks. Also, we protect from critical data stealing by a powerful intelligence firewall. Moreover, our 5G smart pole resists any disruption of data from hackers' attacks by creating a sandboxing environment. AIoT application includes smart lighting, environmental sensing, flood monitoring, and so on. Smart pole backend platform is the dashboard of 5G smart pole system, reflecting current pole status. In conclusion, we have a long-term vision to conceptualize a smart city. When you see to weave a smart city with a high-speed 5G backbone based on 5G smartphone system, which also supports an intelligent C-V2X vehicle smart connected network. Also with the aid from the technology of LEO, low Earth orbit satellite, the smart city concept may extend to a smart world. Here, I'd like to end this presentation with a shining slogan: reshape the urban future, smart cities in a smart world.
Welcome to Computex 2022.